We're going to take a look at inner particle avoidance and collisions now. And these are basically specific parameters found on the p-type, so they're treated separately than regular events. So to basically show this example, I've created two grids emitting the same p-type. So we can actually just go into the p-type PPG, and on there you can go to the inner particle tab, and this is actually where we set the avoidance and collision options. So first thing we're going to look at is the inner particle avoidance. So we'll enable that. And basically, because we're using the same p-type, we want to turn on the enable avoidance with same p-type option. And it's important to remember that this option is set per p-type. So if you have multiple p-types avoiding each other, you need to enable this flag for each p-type. And it's also something worth mentioning is that you can only use p-types within the same cloud to avoid or collide with one another. So you really need to think about this beforehand when you're building your particle simulation. So once we've got that enabled, we can look at the two options here. We've basically got an intensity control and radius control. The intensity basically determines the maximum force the particles will exert to avoid one another. And the radius determines the distance from each particle that the intensity force falls to zero. So you can kind of think of it like this bumper around the actual each particle. So as we increase the radius here, let's go something like 8. And you can see the particles are starting to avoid one another. If I increase the radius quite a bit more, 15, you can see we're getting this effect. In fact, a lot of them, when they're being born off the same emitter, they're actually avoiding each other there. So just to showcase a little more extreme, 25. You can see what kind of effect you're getting there. So let's go back to something like 8. And what we can do is increase the intensity a bit here. So you can see once they go into the radius, the intensity force pushes them away at a higher rate. So we can bring that up a little more. You can see you get a much faster reaction. We can decrease the radius a little bit here to have them get closer. We'll just bring that to something reasonable, 4, or bring that to 10. There we go. And of course, just like all the other particle settings, you've got you can set the actual value based on age, birth, or absolute value, and there's some variability controls. For the collisions, it works in a very similar manner. We'll enable that. We've got the enable collision with same p-type flag on. So probability, this basically determines the probability of a collision occurring. So 0, obviously you've got 0 probability of any collisions occurring. 100% means you've got a 100% chance of collisions. The radius. The radius works similar to the radius option for the inner particle avoidance in that it specifies the minimum distance for the collision to occur. So as we increase this, we're basically increasing the minimum radius that the collision can occur in, and so we're getting a lot more collisions happening. We can bring that up a little bit more. And then finally, we've got elasticity, and this basically determines the elasticity of the particle after the collision. So a value of 1, which is the default, will basically mean the particle will reverse direction and continue with the same speed in the opposite direction. 0 means there's no elasticity in the actual collision. So that was a quick overview. Let's probably just go through a case where we have 2 different p-types with avoidance, just so you get an idea of the workflow there. So what we're going to do is take one of our grids here, the emission property on grid 1, and we're going to define a new p-type on it. And we can edit that p-type. And what we want to do is, you can see what's happening now, is we're not getting any of the actual particles colliding because this guy doesn't have his avoidance flag on. So if we turn this on, now we've got the particles colliding. You'll see it's mostly the p-types from the first one emitting. I'm actually going to change this to a red color or something, make it a little bit bigger. Let's see a better idea what's happening there. and you've got most of the p-type, the first p-type avoiding. What we need to do is increase the radius on the second p-type, so these actually start to take effect in the actual avoidance. So that didn't have much effect. Let's go up to something like 10. There you go. You have the two particles avoiding each other. And it's important to note for a lot of these settings like intensity, the final intensity force you're going to see between your p-types is a product of the two individual intensity values for each p-type. And the same thing applies with the probability for the collision. It'll take the probability for p-type A and p-type B, and that'll be your final probability of collisions occurring. And also that applies to elasticity as well. So it's important to kind of manage each p-type to get the overall simulation looking correct. So anyway, that's a quick look at interparticle avoidance and collisions.